Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Serverless architectures for GenAI pipelines. Serverless architectures have emerged as a transformative approach in the realm of GenAI pipelines, offering scalable, flexible, and cost-effective solutions for data engineering. By decoupling the execution environment from the underlying infrastructure, serverless models enable developers to focus on writing code without the burden of managing servers, thus streamlining the deployment and execution of GenAI models. This paradigm shift is particularly beneficial for handling the dynamic and often unpredictable workloads associated with AI workflows. One of the primary advantages of serverless architectures is their inherent scalability. Unlike traditional server-based models, serverless platforms automatically scale resources up or down based on demand, ensuring optimal performance and cost efficiency. For instance, when deploying a GenAI model for real-time data processing, the serverless approach allows the system to handle spikes in data volume without manual intervention. Amazon Web Services Lambda exemplifies this by offering an event-driven, serverless computing platform that automatically manages resource scaling. This capability is crucial for GenAI applications, where workload can vary dramatically depending on data input and processing requirements. In practice, implementing a serverless architecture for GenAI involves several key steps. Initially, data engineers must define the specific AI tasks and identify the triggers for these tasks. This could involve setting up event sources such as data uploads, changes in database states, or HTTP requests. Once the triggers are established, developers can write functions using languages supported by serverless platforms, such as Python or JavaScript. These functions, often referred to as lambdas in AWS, encapsulate the logic required to process the data and execute the AI models. For example, a function could be written to pre-process incoming data, invoke a machine learning model for prediction, and store the results in a database. A critical component of serverless GenAI pipelines is the integration of managed services to handle various aspects of data processing and storage. AWS offers several services that can be seamlessly integrated with Lambda functions, such as Amazon S3 for object storage, Amazon DynamoDB for NoSQL database services, and Amazon SageMaker for developing and deploying machine learning models. By leveraging these services, data engineers can construct robust, end-to-end GenAI pipelines that are both efficient and easy to maintain. For instance, data can be ingested into an S3 bucket, triggering a Lambda function that processes the data and invokes a SageMaker endpoint to perform model inference. The results can then be stored in DynamoDB for further analysis or reporting. Security is another critical consideration in serverless architectures, especially when dealing with sensitive data in GenAI applications. Implementing robust access controls and encryption mechanisms is essential to ensure data privacy and protection. AWS Identity and Access Management provides fine-grained access control, allowing developers to specify who can access specific resources and actions. Additionally, services like AWS Key Management Service can be used to encrypt data at rest and in transit, adding an extra layer of security to the GenAI pipeline. Despite the numerous advantages, serverless architectures also present certain challenges, particularly in the context of GenAI. One such challenge is the cold start latency, which refers to the delay that occurs when a serverless function is invoked for the first time or after a period of inactivity. This can impact the performance of real-time applications where low latency is critical. To mitigate this issue, developers can adopt strategies such as keeping functions warm by periodically invoking them or optimizing the function code to reduce initialization time. Google Cloud Functions offer a similar serverless environment, and developers can use its always-on feature to minimize cold start delays. Another challenge is the stateless nature of serverless functions, which necessitates the use of external storage solutions to manage stateful operations. In GenAI pipelines, maintaining the state of data processing tasks is often crucial, especially in scenarios involving sequential data transformation steps. To address this, engineers can utilize managed stateful services such as AWS step functions, which orchestrate complex workflows by coordinating multiple serverless functions and maintaining state across executions. This allows for the construction of intricate GenAI pipelines that can handle complex dependencies and task coordination. The cost-effectiveness of serverless architectures is a significant factor driving their adoption in GenAI applications. With a pay-per-use pricing model, organizations only incur costs for the actual compute time consumed by their functions, rather than paying for idle server capacity. This is particularly advantageous for startups and small businesses that may not have the resources to invest in large-scale server infrastructure, but still require powerful AI capabilities. By adopting serverless solutions, these organizations can leverage cutting-edge AI technologies without incurring prohibitive costs. Practical tools and frameworks play a pivotal role in enhancing the implementation of serverless architectures for GenAI. The Serverless framework, an open-source tool, simplifies the deployment and management of serverless applications across multiple cloud providers, including AWS, Google Cloud, and Microsoft Azure. It abstracts away the complexities of infrastructure configuration, allowing developers to define their serverless functions and resources declaratively in a simple configuration file. This not only accelerates the development process, but also promotes best practices in infrastructure as code, enabling version control and collaborative development. For a comprehensive understanding of serverless architectures in GenAI, examining real-world examples and case studies provides valuable insights. A notable case is Netflix, which leverages serverless platforms for its data processing and analysis workflows. By utilizing AWS Lambda and other serverless services, Netflix has optimized its data pipeline, achieving greater scalability and efficiency in processing large volumes of streaming data. This has enabled the company to deliver personalized content recommendations to millions of users worldwide, demonstrating the power of serverless architectures in handling complex AI-driven tasks. In conclusion, serverless architectures offer a compelling approach for implementing GenAI pipelines, combining scalability, flexibility, and cost-effectiveness. By harnessing the capabilities of serverless platforms and integrating managed services, data engineers can construct robust and efficient AI workflows that meet the demands of modern data engineering. While challenges such as cold start latency and state management exist, they can be addressed through strategic design choices and the use of orchestration tools. The adoption of serverless architectures is poised to transform the landscape of GenAI, empowering organizations to unlock the full potential of AI technologies without the complexities of traditional server management. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UExcel, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.